Hello everyone. In the previous session we have learned the theorem of Taylor's theorem, proof of Taylor's theorem and Lorentz theorem, and we have solved problems on radius of convergence. So in this session let me solve problems on Taylor series. Before getting to the Taylor series, let me revise the concept that I have already done in the previous session. That is, as you already know that Taylor's theorem is given by, Taylor series is given by f of z is equal to f of z naught plus summation n is equal to 1 to infinity z minus z naught power of n divided by n factorial into f power of n of z naught. So this is the Taylor's theorem statement in case of complex plane. Fine. So as I already told you, this is a Taylor's expansion. Suppose when you are going to take z naught as 0, so as usual in case of series that you already learnt in UG classes, so whenever you are going to replace z with or x with initial value 0, you are going to get Taylor series reduces to meclurian series. So here also when you are going to replace z naught with 0, you will get f of z is equal to f of 0 plus summation n is equal to 1 to infinity z power of z minus z naught is 0, so z minus 0 is z power of n by n factorial f power of n of 0. Fine. So this series is called as meclurian series. Meclurian series, in the sense when you are going to replace an initial value with a 0 in Taylor's theorem, you will get a meclurian series. Fine. Now coming to the problem. So here you have a first problem. We have to expand this expansion by using Taylor series. About first condition is mod z is equal to 0. So as I said, now whenever we are going to replace z naught with z is equal to 0, we are going to get meclurian series. Anyhow, we can also say this as a meclurian series. So first let me solve this. So before solving the problem, I am telling you once again, after finishing radius of convergence, I'll just send you the note point, that is meclurian series and Taylor series. I'll just send you 3 lines of note point. You just copy that note point after the radius of convergence problems. Fine. After that note, you have to start with the heading problems and Taylor series. Again, notes of this will not be sent in the group. Please copy from the video itself. Put the heading problems and Taylor series and write down this problem. Solve as I'm doing here. Fine. First let me write down the Taylor series expansion. So what it is, we know that f of z is equal to, I am going to write the expansion, f of z naught plus z minus z naught divided by 1 factorial into f dash of z naught plus z minus z naught whole square divided by 2 factorial into f double dash of z naught plus so on. It will be continuing. So this is what the Taylor series expansion is. Fine. Now what I'm going to do is, let me consider the function as f of z. So it is given by z minus 1 divided by z plus 1. Now what we need to calculate is f dash and f double dash. It represents the derivative of a function. So let me calculate derivative. That is f dash. Differentiate this one time. So when you're going to differentiate, you will get denominator whole square. Quotient rule you have to apply. Denominator whole square into denominator into derivative of numerator. With respect to z we are differentiating, so you will get 1 with respect to z, and for 1 you are going to get 0 minus numerator z minus 1 into derivative of denominator is z plus 1. I'm repeating once again, denominator whole square, denominator into derivative of numerator minus numerator into derivative of denominator is 1. So differentiation of 1 is 0. 1 plus 0 you will get. So after simplification I can write this as z plus 1 minus z. So it is 0. 1 plus 0 is 1. 1 into anything will be 1. So minus of minus will become plus 1. You just differentiate it. That's all. So here plus z minus z cancel. So what you're going to get, f dash of z as 2 divided by z plus 1 whole square. Similarly, let us find f double dash. For 2 terms I'm going to find. So you have to differentiate it again. Fine. Now let me differentiate this. When you differentiate, you will get z plus 1 whole power of 3 minus 4. You just shift this to numerator, so you will get differentiation and all basic steps. I am not going to explain this once again. You have to remember. Fine. I can write like this. Now 2 as it is. Now it is of the form x power of n. So you will get minus 2 into z plus 1 power of minus 2 minus 1. So you will get minus 4 into z plus 1 power of minus 3. Fine. So again I can write this as minus 4 divided by z plus 1 cube. So in each and every step I cannot explain differentiation, so you have to do by your own. So f double dash I have done. Now we have to calculate for the first problem. I have to replace z with 0. So first let me substitute here. F of z is equal to f of z naught. In the sense z naught value you have to put it as z is equal to 0. First let me calculate all the values. Afterwards it is easy to simplify. So what do we need is, I'll just write here f of 0 plus z is as it is minus 0 divided by 1 factorial into f dash of 0 plus z minus 0 whole square divided by 2 factorial into f double dash of 0 plus so on. This is what the expansion is. That is f of 0 plus z into f dash of 0 plus z square divided by 2 factorial into f double dash of 0 plus so on. This is what we need is. Now let me calculate the terms that we required. F of 0 we need. So replace z with 0. 0 minus 1 divided by 0 plus 1. So you will get minus 1. F of 0 is minus 1. Similarly calculate f dash of 0. Here you have f dash of z. So replace z with 0. So you will get 2 divided by 0 plus 1 whole square. So 2 divided by 1 it is 2. So f double dash of 0 I have done. Next I have to calculate, I'll just do here f double dash of 0. F double dash of 0 in the sense f double dash I have here. So let me replace z with 0. So you will get minus 4 divided by 0 plus 1 whole cube. So after simplification you will get minus 4. Now substitute all this term in the expansion. You will get f of z is equal to f of 0 is minus 1 plus z is as it is, f dash of 0 is 2, so you will get 2z here plus z square by 2 factorial into f double dash of 0 is minus 4 plus so on, or else I can write this as minus 1 plus 2z minus 4z square divided by 2 factorial plus so on. This term should be there. Why? Because it is all infinite series expansion. So f of z, required f of z about the point z is equal to 0 is this expression. Now we have solved for first case, that is for z is equal to 0. Now for the second problem, see the problem is here. So I have solved it for z is equal to 0. So this is the expansion you have. So after listening, understanding the problem, you just pause the video and you just take a screenshot of this and you just write down it in the notes. So it is better method. Fine. So now we have to find about z is equal to 1. Fine. Z is equal to 1. What I'm going to do is I'll just replace z is equal to 1 in the standard expansion. Fine. See here in the standard expansion I'll put z is equal to 1. So when you do that you will get f of z is equal to, z naught is equal to 1 you have to replace. Here also z naught is equal to 0. So you will get f of 1 plus z minus 1 divided by 1 factorial into f dash of 1 plus z minus 1 square divided by 2 factorial into f double dash of 1. So this is what we require to find is. Now f of 1 value I'll just find. F of 1 in the sense f of z I have here, replace z with 1. So you will get 1 minus 1 divided by 1 plus 1. 1 minus 1 is 0, by anything is 0. Next we need f dash of 1. I have done f dash here. So let me calculate, replace z by 1. You will get 2 divided by 1 plus 1 whole square. So it is 2 divided by 2 square is 4. So 2 1s are 2 2s are. You will get 1 by 2. Similarly let me calculate f double dash of 1. So minus 4 divided by z value is 1. That is z naught. Z in the sense z naught only. We need f of z naught. So z you have to replace it with 1. Anyhow you just take it as z only. So but in the expansion you have to understand the concept. Fine. Meaning is that the given point should be taken as z naught and you have to replace these values in place of z naught. So minus 4 divided by, replace z with 1 we need, right? So f double dash of 1 we need. So replace z with 1, you will get 1 plus 1 whole cube. So you will get minus 4 divided by 2 cube. It is minus 4 divided by 2 cube is 8. So 4 1s are 4 2s. Again you will get minus 1 by 2. So substitute all these expansion in the expression. So you will get f of z is equal to, f of 1 is 0. So you leave it. Next z minus 1 divided by 1 factorial into f dash of 1 is 1 by 2. So I'll just write 2 here. Fine. Next term is plus z minus 1 whole square divided by 2 factorial into minus 1 by 2. Now plus so on, these terms will be continuing. I can rewrite the same expression as f of z is equal to z minus 1 factorial is 1 into 2 is 2 plus z minus 1 whole square, 2 factorial is 2. So minus if plus will become minus. 2 into 2 is 4. So z minus 1 whole square by 4 plus so on. So this is the required Taylor series expansion about the point z is equal to 1. So this is what the required solution is. Now you can take the screenshot of second problem. So this is the first problem solution. So I'll just give you the hint. With a given problem, first you write down the expression and take the given function as f of z. Next differentiate it 1 time and 2 time. Next replace the given values in place of z0 and expand it, and substitution will give you the answer. Now let us hope so it is clear for you. Now let me solve one more problem. Here is the second problem, and it is important problem. It is quite different. Fine. So we have to expand this in the region given. Fine. Before that, let me take the function, given function as f of z. It is taken as f of z is equal to z square minus 3z plus 2. Now we have to factorize the denominator. Use the factorization method and factorize it. You will get z minus 2 into z minus 1. Fine. So you just apply factorization method. So I can write this as z minus 2 into z minus 1. If you multiply these two terms, you will get back this one and the same. So I cannot do this once again. You have to do by your own. Now let me consider this 1 by z minus 2 into z minus 1. So let me split this by using partial fraction. So why? Because it is of the form product of two terms. So I can split by using partial fraction. So I can write this as a into z minus 1 plus b into z minus 2. Let me replace z is equal to 1. So you will get 1 is equal to b into 1 minus 2. That is b into 1 minus 2 is minus 1. So the value of b is minus 1. Now let me replace z is equal to 2. So you will get 1 is equal to a into 2 minus 1. So 1 is equal to a into 1. That is a value is 1. Since I have obtained a and b value, I can write f of z as, I am going to split this as a is 1 divided by z minus 2 plus b is minus 1. So I can write minus 1 divided by z minus 1. So I have obtained the function f of z now. Now let me solve the first one. So we have to expand this function. This is z. We have to expand this function. It is minus. Why? Because b is minus 1. Fine. We have to expand this function about mod z less than 1. About this curve we have to expand. Since I have obtained f of z, now we can expand this. Meaning of this expression is, whenever you have mod z less than 1, we can take z in the denominator to the numerator. In the sense, I'll just write it here. Suppose whenever you have the term like 1 divided by 1 minus z, you can write the same as 1 minus z power of minus 1 when mod z less than 1. Suppose I'll give you one more example. Suppose say I have 1 divided by 1 minus z minus 2. So I can take this, I can write this as 1 minus z by 2 whole power of minus 1 only when the condition given such that mod z by 2 is less than 1. So if this condition is true, I can write like this. Similarly, if mod z is less than 1, if this condition is true, I can write like this. Clear? So for mod z less than 1, we have to solve. Fine. Let us consider a given function. So the given function is f of z is equal to 1 divided by z minus 2 minus 1 divided by z minus 1. Now I can write this as, see here, I am just rewriting this expression. Before that, let me take 2 as a common term. So you will get 1, or else let me take minus common. If you want, you can simplify as it is. So when you take 2 as a common, you will get z by 2 minus 1 minus 1 divided by 1 as common. So you will get z minus 1. It doesn't change. Right? So when you're going to shift this in the denominator, as I said, so you will get what the expression will become. You just check 1 by 2 into, you will get z by 2 minus 1 whole power of minus 1 minus z minus 1 whole power of minus 1 you have. Clear? Now we cannot expand how the term occurs. Why? Because we have expression for 1 minus x power of minus 1 if mod x is less than 1. Since it is given that mod z is less than 1, so you have to first rearrange the term as per the standard form, that is 1 minus x form. So for that, 1 should be there in the first position. So let me take minus as a common term. So I'll just continue here. So that f of z can be written as, I'll just take minus common term. So I can write this as minus 1 by 2 into 1 minus z by 2 whole power of minus 1 plus again I am going to shift this, take the common factor as minus 1. So I can write 1 minus z power of minus 1. Why? Because whenever we have mod x less than 1, then we can express it in a standard form 1 minus x power of minus 1. Here we have mod z less than 1, but we don't have 1 minus z here. Instead we have z minus 1. So we have to make it as 1 minus z. For that I have taken minus as a common term in both the terms. So it become minus 1 by 2 into 1 minus z by 2 whole power of minus 1. So plus into minus will become, originally you have minus here. So minus of minus will become plus 1 minus z power of minus 1. You make it as minus. Why? Because you have already minus there. When you take minus as a common term, so minus of minus become plus then. So 1 minus z power of minus 1 you will get. So now you can apply the expansion here. So minus 1 by 2 as it is. So as I already told you, 1 minus x whole power of minus 1 will be 1 plus x square plus x cube plus so on. So I am going to apply the same. 1 minus x power of minus 1 is 1 plus x is z by 2 plus x square is z square by 4 plus so on. Plus similarly here also 1 plus z square plus so on. Fine. So you can add the terms, that is minus 1 by 2 plus 1 is 1 by 2. Next z by 2 plus z is 3 by 4 times z plus 1 by 4 plus 1 into z square. See here 1 by 4 plus 1 into z square, common term, right? I am combining these two expressions. So you will get, after taking the LCM, 4 plus 1 is 5. 4 is LCM here. See here z square coefficient is 1 by 4 here. In this 1 by 4 into minus 1 by 2 you have. So minus 1 divided by 8 you will get here. So if you take LCM, hope so you understand this concept. See here z by 2 coefficient, here for 1 you have minus 1 by 2. Here constant is 1. So if you simplify these two you will get 1 by 2. Similarly z by 2 coefficient is minus 1 by 2 into 1 by 2. Here z coefficient is 1. So when you multiply you will get minus 1 divided by 4 plus 1. So if you simplify minus 1 plus 4 divided, so if you simplify you will get plus 4 minus 1 is plus 3. So you will get plus 3 by 4 times of z. Similarly what you have for z square coefficient, it is minus 1 by 2 into 1 by 4. Here z square coefficient is 1. So plus 1. You will get minus 1 divided by 8 plus 1. So if you take LCM you will get minus 1 plus 8 divided by 2. It is 7 by 8 times z square. So this is the required expansion of a given problem. Fine. About mod z less than 1. So in this particular problem we have 3 sub questions. So this is the answer for mod z less than 1. So we have done it for when mod z less than 1. Similarly we have to do the second one. So let me write the second condition given. So second one is, what is the given expression? I'll just write here. 1 less than mod z less than 2. So this is what the given data is. Now let me simplify this. The meaning of this expression is, first condition either 1 less than mod z or mod z less than 2. Meaning is I can write this as, see here I'll just rewrite this statement. I can, when you take reciprocal, remember I'll just reciprocate. So reciprocal in the sense, whenever you are going to reciprocal, when you take reciprocal I can write this as 1 by z is less than 1. Fine. I'll just write here. So 1 less than mod z can be written as mod z greater than 1. So when you take reciprocal you will get mod z. When you take reciprocal, greater than will become less than, 1 by 1 is 1. So 1 by mod z is less than 1. So second condition is mod z less than 2. So similarly here also I can write, let me take 2 here. So mod z by 2 is less than 1. So meaning is that whenever you have z by 2 in the denominator, something like 1 divided by 1 minus z by 2, I can write this as 1 minus z by 2 whole power of minus 1. Fine. Now let me rewrite the given function. So given function is f of z is equal to 1 divided by z minus 2 minus 1 divided by z minus 1. Clear? Now what I'm going to do is I'm going to take 2 as a common factor. So let me take 2 as a common. So you will get, as I said earlier, you have to take negative again. So instead of that, let me take minus 2 as common term. So you will get 1 divided by z by 2. Minus 1 divided by, I'll take minus common here itself. So minus of z I'll take common. So 1 minus 1 by z you will get. Fine. So let me take z as common term. So you can write 1 divided by 1 by z. Why? Because given 1 by z is less than 1. Anyhow, when you take z as common term, you will get the standard expression, right? So I can write this as 1 divided by minus 2 into 1 minus z by 2 minus 1 divided by z into 1 divided by 1 minus 1 by z. Now I can rewrite the same as f of z is equal to minus 1 by 2 into 1 minus z by 2 whole power of minus 1 minus 1 by z into 1 minus 1 divided by z power of minus 1. So I have shifted the terms in the denominator to the numerator. Now we can apply the expansion of the term. So you will get 1 by z is equal to minus 1 by 2 into 1 minus x power of minus 1 is 1 plus x square plus x cube. So I am applying the same. This is only for your understanding purpose. No need to write these concepts in your notes. If you understand this, you can write it in your own steps. So 1 minus x power of minus 1 is 1 plus x square plus so on. Minus 1 by z into, similarly here also 1 plus 1 by z plus 1 by z square plus so on. Now let me simplify. So you will get f of z as, let me multiply inside. So you will get minus 1 by 2. Next term, minus 1 by 4 times of z. If you add and simplify, you will get, if you want, you can cross check. I am not going to do it for all the terms. Fine. What am I doing is, I am just multiplying the term minus 1 by 2 inside. So minus 1 by 2 into 1 is minus 1 by 2. Minus 1 by 4 times z. Next minus 1 by 8 times z square. So on. Minus 1 by z into, you just combine the terms. So 1 by z plus 1 by z into z square plus 1 divided by z into z square is z cube plus so on. So this is the required expansion. Again, no need to simplify, you just keep as it is. So further simplification may not be required. So this is the solution for the second problem. Now we have two more problems, that is third one. Third one is mod z greater than 2. I am just showing you once again. See here, you just write down the problem. For the first problem, before solving first problem, you split the function f of z and rewrite this statement. Next, solve the first problem. So this is the solution for the first problem, right from here to here. Fine. No, this simplification will be for your reference. Next, second problem, right from here to here. Clear? Now let me solve the third problem. Third sub question. I'll just write third sub question here. Third sub question is mod z greater than 2. So whenever mod z is greater than 2, I can write 1 by z is less than 1 by 2. I am taking reciprocal, so greater than will become less than. Again, I can write 2 by z. Just do the cross multiplication. 2 by z is less than 1. Fine. Now let me simplify. Let us write down the function f of z once again. As we already simplified, f of z is 1 divided by z minus 2 minus 1 divided by z minus 1. Now since we have 2 by z, so we have to take z as a common term, so that you will get 2 by z here. So f of z will be 1 divided by, let me take z as common, you will get 1 minus 2 by z. Fine. Minus 1 divided by, since 1 by z is there, so let me take z as common, so 1 minus 1 by z. Now we can rewrite the terms as we done in first two cases. So 1 by z into 1 minus 2 by z whole power of minus 1 minus 1 by z into 1 minus 1 by z whole power of minus 1. So this is the f of z. Now let me simplify further. F of z is equal to 1 by z into, expand this, that is 1 minus x power of minus 1 expansion 1 plus x square plus so on. Similarly, 1 plus x is 2 by z plus x square in the sense 4 by z square. Similarly, you will get more terms. Let me end here itself. 1 by z. Again, it is 1 plus 1 by z plus 1 by z square plus so on. Fine. Again, if you want, you can simplify. Otherwise, you just leave here itself. You just multiply the terms. F of z is equal to 1 by z plus 2 by z square plus 4 by z cube. I have multiplied 1 by z inside, that's all. Next, minus 1 by z inside, so minus 1 by z. You just open the term if you want, if you open the bracket if you are multiplying minus, otherwise keep bracket as it is. So plus 1 by z square, I am multiplying just 1 by z, not opening minus, in the sense not multiplying minus. So 1 by z cube plus so on. This is what the required expansion is. I have multiplied 1 by z inside. This is the solution for third one. Now let me solve the last expression, that is fourth one. So here is the fourth expansion, fourth problem. 0 less than mod z minus 1 less than 1. Fine. Now let me rewrite the given problem in required form. So f of z is 1 divided by z minus 2 minus 1 divided by z minus 1. Now how can we write z minus 2 as? Why? Because we have mod z minus 1, condition for mod z minus 1. So we have to arrange the given term in a required format. So f of z can be written as 1 divided by z minus 1 minus 1. Minus 1 minus 1 will be minus 2 again. So I can write like this, minus 1 divided by z minus 1. So it can be written as second term as usual z minus 1 power of minus 1. So whereas the first term, let me simplify this. Let me take minus 1 as common term. So you will get 1 minus z minus 1. So if you multiply minus inside, you will get back the previous step. So my f of z will be, I'll just 1 divided by minus 1 is minus 1. So 1 minus z minus 1 whole power of minus 1 minus z minus 1 whole power of minus 1. Hope you understand. Right? See, minus 2 can be written as minus 1 minus 1. Now minus 1 common factor, so these terms get reversed. Next 1 divided by minus 1 is minus 1. This term shifted to numerator. Now you can expand this function as usual by using the standard expression. Now it can be written as minus 1 into 1 plus x in the sense z minus 1 plus x square in the sense z minus 1 whole square plus so on minus, this is of the form 1 plus z square. Before that, make sure that this point cannot be expanded, right? Why? Because it should be of the form 1 minus z whole power of minus 1, but it is of the form z minus 1 whole square. So you can take minus common factor. So if you take minus as a common factor, you can put plus here. See here, z minus 1 can be written as minus of 1 minus z. If you multiply minus inside, you will get back the previous step, this term, right? So I can expand this now, z cube plus so on. Now let me multiply minus 1 inside. So you will get minus 1 minus z minus 1 minus z minus 1 whole square. So on, minus will be there. So on will continue. Minus, if you want, you can retain this term as it is, or else you can write this as plus of 1 minus z whole power of minus 1. And remember, this is called as principal part and this is called as analytical part. Analytical part. This is principal part. Principal part. In the previous problem also, this is called as analytical part. Analytic part. Fine. This is called as principal part. Principal part. So this is the required solution for the given problem. So we have solved all the 4 sub questions here. Hope so it is clear. You copy the 3rd and 4th question. Fine. Next, let me solve one more problem. So hope you pass the video and you just copy down these problems in your notes. So now let us solve the next problem. So here is the next problem. Now we have to expand this by using the Taylor series. Whatever I am doing now is based on the Taylor series only. So expand using Taylor series. If you want, you can add using Taylor series. Now we can note that the function f of z, first step, if you want, you can write the series, that is Taylor series is given by, hope you remember the concept. You have to write the formula for all the problems. So f of z is equal to f of z naught plus z minus z naught divided by 1 factorial into f dash of z naught plus z minus z naught the whole square divided by 2 factorial into f double dash of z naught plus so on. So this is the required Taylor series expansion. Next, you take the given function as f of z, 1 divided by z minus 1 into z minus 2. So given a problem, first you write down Taylor series expansion. Next, consider the given function as f of z. Now you split this function by using partial fraction. So I can write z minus 1 into 1 divided by z minus 1 into z minus 2 as a divided by z minus 1 plus b divided by z minus 2. Fine. So you will get 1 is equal to a into z minus 2 plus b into z minus 1. Now let me give the value of z as 1. So if you keep z is equal to 1, you will get a into 1 minus 2. So after simplification, you will get 1 minus 2 is minus 1, so that the value of a is minus 1. Now let me substitute z is equal to 2. So you will get b into 2 minus 1. So after simplification, you will get b is equal to 1. So a is equal to minus 1. Therefore, the function f of z can be written by expanding, that is minus 1 divided by z minus 1 plus b is 1 divided by z minus 2. Now this is the required function to us. Now given that mod z is less than 1. So as per the given condition, keep on expanding this term. Before that, Remember, for this term mod z should be less than 1. For this term mod z minus, anyhow it is not given, so we can express it in the form of 1 minus z power of minus 1. So let me expand this. Before that, let me rewrite this. Since I have z minus 1 in the denominator, let me take minus as a common term. So you will get 1 minus z here. In the denominator of this term, I am going to take 2 as a common term. So you will get, instead of 2, let me take z as common term, so that you will get standard form 1 minus 2 by z. I'll give you one short key point, that whenever you are expanding the term, make sure that z should be in the numerator. Fine. While taking the common factor, you just make sure that after expanding the term z should comes to numerator. But when you expand this term, even though it is in standard form, when you expand this term, you will get z in the denominator. So arrange this term in such a way that z comes to numerator. Fine. So when the z comes to numerator, only when you take 2 as a common term. So let me take 2 as a common term. So when you are going to take 2 as a common, you are going to get z divided by 2 minus 1. I'll just write it once again. Minus minus get cancelled. 1 divided by 1 minus z plus 1 divided by 2 into z by 2 minus 1 you will get. Why? Because z should be in the numerator. Now you can check that it is of the form z minus 1, but we should require a from 1 minus z, right? So let me take minus as a common term in the second term. So let me take minus, so you will get minus here. I can write this as 1 minus z by 2. Why? Because I have taken minus as a common term to convert it into standard form. Fine. Now we can rewrite this as f of z is equal to 1 minus z power of minus 1 minus 1 by 2 into 1 minus z by 2 power of minus 1. Now you can easily expand as it is in its standard form. So when you expand this term, you will get f of z is equal to, this is of the form 1 plus z square plus so on, minus 1 by 2 into, this will be of the form 1 plus z by 2 plus z square by 4, that is x square, right, plus so on. So this is called as analytical part. This is called as what we say, as I already told you in the previous problem, first term will always represent analytical part, second part is principal part. Either you can stop here itself. If you want, you can simplify just by taking the common factors. See, 1 minus 1 by 2 you have. 1 minus 1 by 2. I'll just show you for one problem. I'll just continue here. See here, I can write this as f of z is equal to 1 minus 1 by 2. Plus, you just take z as a common term. What is the term here? 1. Here, minus 1 by 2. Am I correct? Next, let's collect the terms containing, 1 by 2 is, again multiplication is there, right? Coefficient of z will become 1 by 2 into 1 by 2. That is minus 1 by 4. Again, when you take z square coefficient, here it is 1 minus, here minus 1 by 2 into 1 by 4. It is minus 1 by 8. Fine, plus so on. So after simplification you will get, it is 1 by 2 plus 34 minus 1 is, see here you can take 4 as a common factor. So 4 minus 1 is 3 divided by 4 into z. Right, 1 minus 1 by 4. 4 minus 1 is 3 divided by 4 into z you will get. Plus 8 minus 1 is 7 by 8 z square plus so on. Either you can simplify this or you can keep up to here only. So one and the same. So this is the required Taylor series expansion of the given problem. Fine. You just pause the video and copy down this problem. Pause the video and please take the screenshot. So this is the complete solution of Taylor series expansion of a given problem. So pause the video and take a screenshot and copy down the same. It is 2 into z minus 2 minus 1. Why? Because I have taken 2 as a common term in order to arrange it in a standard expression, that is 1 minus z. Hope so it is clear. Here is the next problem. Fourth problem, we have to solve by using Taylor series expansion about the point mod z less than 1. So as usual, first write down the Taylor series expansion solution. Taylor series is given by, I'll just write the step for this problem. For the next problem you have to write, is given by f of z is equal to f of z naught plus z minus z naught divided by 1 factorial into f dash of z naught plus z minus z naught whole square divided by 2 factorial into f double dash of z naught plus so on. Now let us consider the given function as f of z. F of z is equal to z divided by z square minus 1 into z square plus 4. So these two steps are common for all the problems. Even though I am not going to write, you have to write these two steps for all the problems. Fine. Next, consider the denominator. So we have to expand the denominator, right? Why? Because it is of the product of two terms. So let me consider the denominator z square minus 1 into z square plus 4. Now we have to resolve this by using partial fraction. So let me split it as, see here, z square minus 1 can be written as, I'll just write one more step, it is z plus 1 into z minus 1. Similarly, z square plus 4 can be written as z plus 2i into z minus 2i. When you multiply, you will get back the same step. If you don't know, if you can simplify here, z square plus 4 is equal to 0. So z square is equal to minus 4. Z is equal to plus or minus square root of minus 4. So z is equal to plus or minus I into 4. So one value is z minus I4. Square root of plus or minus I into 2, right? I'm sorry, the square root of 4 is 2. Another value is z plus 2i. So that is what I have written here. See here, z square plus 4 is equal to 0, z square is equal to minus 4. So when you take square root on both sides, so you will get this as 2. So z minus 2i into z plus 2i. So that is how I have written z square plus 4 as product of these two terms. Now let us consider this term, that is 1 divided by z plus 1 into z minus 1 into z plus 2i into z minus 2i. Now we can split this by using partial fraction. So a divided by z plus 1 plus b divided by z minus 1 plus c divided by z plus 2i plus d divided by z minus 2i. Now we can solve it by using the partial fraction. So let me write one more step. 1 is equal to a into z plus 1 will not be there. So you will get z minus 1, z plus 2i into z minus 2i. Plus b into z minus 1 will not be there. So what you have, z plus 1 into z plus 2i into z minus 2i. Next, plus c into z plus 2i will not be there. So z plus 1 into z minus 1 into z minus 2i. Plus c into z minus 2i will not be there. So z plus 1 into z minus 1 into z plus 2i. So this is what we have. Now let me substitute the value of z is equal to 1. So you will not get minus 1 term. Why? Because when you put z is equal to 1, this term will be 0. Again this term and this term will be 0. So only term you get is b. So b into z is equal to 1. 1 plus 1 is 2. Again 1 plus 2i you will get into 1 minus 2i. Right? You have to simplify this. So anyhow let me simplify. It is of the form a plus b into a minus b. I can write a square minus b square. Right? So 1 is equal to b into 2 into 1 square is 1 minus 2 square is 4. I square is minus 1. So minus of minus will become plus. Now 4 plus 1 is 5. 5 into 2 is 10. So 1 divided by 10 is b. B value is 1 divided by 10. Now let me simplify the next term. Let me substitute. It is 1 divided by 10. Fine. B is equal to 1 divided by 10. So let me substitute z is equal to minus 1. So when you put minus 1, plus 1 terms will not be there. Replace it with minus 1. This term will be 0. Again this term 0. This term 0. So you will get a value. So 1 is equal to a into minus 1 minus 1. Minus 1 plus 2i into minus 1 minus 2i you will get. Fine. So after simplification, 1 is equal to a into minus 1 is minus 2. Next, it is of the form a plus b into a minus b. So it can be written as a square minus b square. A plus b into a minus b. B square is 2i whole square. So 1 is equal to a into minus 2. Minus 1 square is 1. Minus 2 square is 4. I square is minus 1. So minus of minus will become plus. 4 plus 1 is 5. 5 2s are 10. So minus 10 you have. So minus 1 divided by 10 will be the value of a. Fine. Similarly, let me replace z with say 2i. So when you put 2i, minus 2i will not be there. So 2i minus 2i 0. So this term also 0, this term also 0. So you will get d value. So 1 is equal to d into 2i plus 1 into 2i minus 1 into 2i plus 2i you will get. So let me simplify this. See here, a plus b into a minus b. These two terms a plus b into a minus b. So I can write this as a square minus b square into 2i plus 2i is 4i I can write. So 1 is equal to d into 2i square is 4 into I square value is minus 1. So I can write minus 4 minus 1. Fine. Into 4i I have. Next minus 4 is minus 4 minus 1 is minus 5 into 4 into I. So d value will be 1 divided by minus 5 4s are 20. right? So d is equal to 5 4s are 20 into I minus 1 divided by 20I. Now let me replace z as minus 2I. So you will get the value of c. 1 is equal to c into minus 2I plus 1 minus 2I minus 1 into minus 2I minus 2I. Fine. So let me simplify this. C into, now this is of the form a square minus b square. So a square minus b square, you will get minus 4I here. Now 1 is equal to c into minus square is plus. So 2 square is 4. I square value is minus 1. So minus 1 minus of plus become minus. See here, 2 square is 4. Minus square is plus. I square is minus 1. So I have written minus 4 here. Minus 1 into minus 4I. Now minus 4 minus 1 is minus 5. So minus 5 into minus 4I. So you can write C as 1 divided by minus into minus plus 5 4s are 20I. Clear? So C value is 1 divided by 20I. Similarly, D value is minus 1 divided by 20I. So I have obtained all the values of A, B, C and D. Now let me substitute so to get the value of f of z. So I'll just continue here. So f of z is where I have written by splitting the fraction. So here it is. F of z is equal to z into z divided by z plus 1 you will get. Why? Because denominator is splitted here by applying the partial fraction, right? So z divided by z plus 1 into a. A value is minus 1 by 10. So I can write this as minus 1 by 10 into z divided by z plus 1. Next b value is 1 divided by 10. So plus 1 divided by 10 into z divided by z minus 1. Clear? Numerator, why? Because in the function you have numerator z, so I have not considered z in the partial fraction, so I have to write z here. Next, c value is plus 1 divided by 20I into z divided by z plus 2I. Next value, d value is plus 1 divided by, d is minus, right? So minus 1 divided by 20I into z divided by z plus 2I. So whatever I have done is, I have considered the given function as f of z and I have applied the partial fraction to resolve it into 4 terms. That is sum of 4 terms, and I have expressed the value. I have obtained the values of a, b, c and d, and I have substituted by splitting the denominator, and I have obtained this. Now we have to expand this about the point mod z less than 1. That is just the Taylor series expansion. So you just keep all the terms as it is and apply. So minus 1 by 10 as it is. Fine. So we are applying, since we are applying it only for the denominator, right? Why? Because in the numerator we have z here, so we cannot expand it, so we have to consider only denominator, that is 1 divided by z plus 1 plus 1 by 10 into 1 divided by z minus 1. Why? Because we have expanded it, we have splitted only denominator, so z will be there, but to apply Taylor series we have to consider only denominator. So 1 by 20I into 1 divided by z plus 20I minus 1 by 20I into 1 divided by z plus 2I. Clear? Z in the numerator, anyhow you just leave it, you just write down this. Now you can apply the theorem, that is Taylor's expansion. It is given by a value is minus 1 by 10. So minus 1 by 10 into 1 divided by z plus 1 can be written as z minus 1, z plus 1 power of minus 1. Similarly, plus 1 by 10 into z minus 1 power of minus 1 plus 20I into z plus 2I power of minus 1 minus 20I into 1 by 20I into z plus 2I power of minus 1. Now we can expand this. See here, minus 1 by 10 into 1 plus z square. We have plus here, right? That is, I can write this as 1 plus z power of minus 1. So alternatively, negative and positive number. That is 1 minus x plus x square minus x cube. So like that you will get. You can make a difference here. 1 minus z plus z square minus z cube plus so on you will get. Next for the second term, plus 1 by z into, now you have to take minus as a common term. So more the problems you solve, more idea you will get. So here I am going to take a common term as a minus. So I just make it as minus in order to apply form. Why? Because it should be 1 minus z power of minus 1. So minus 1 by 10 into 1 plus z square plus so on. Next third term will be 1 by 20I into, here also it is of the form like 1 plus z power of minus 1, right? So here also you have to take alternatively positive and negative numbers. That is, first term will be 1. Before that, let me take 2i as a common term. So if you want, I'll just write it in one more step. You just leave it. Why? Because if I do directly, you will not understand. So I'll just do one more step. So I can write this as 1 plus z power of minus 1. So this term as it is, that is, I'll just take common term. So you will get minus 1 by 10 into 1 minus z power of minus 1. I'll just do one more step. If I write directly, you will not understand. That is why I'm doing one more step. So let me take 2i as a common term. So you will get 1 divided by 20i into 2i I am going to take common, so you will get z by 2i plus 1 whole power of minus 1 minus 1 divided by 20i as it is. Again I am going to take 2i as common. So when you get 2i as a common term, so I'm sorry, in the d term, denominator of d is z minus 2i. So last term too should be z minus 2i. I'm sorry, sign mistake, it is z minus 2i. So you will get minus here. Fine. Now let us take, I'm sorry, this is for third term, right? See here, I'm extremely sorry for this. See here, first term I have written as it is, second term minus common factor, third term I have taken 2i as common factor, so plus will be there as it is plus. Now look at the third term, minus 1 by 20i, you will get, when you take 2i as a common term, you will get z divided by 2i minus 1, whole power of minus 1, but we required it is in the form of minus, so let me write one more step. So I can write f of z as minus 1 by 10 into 1 plus z power of minus 1 minus 1 by 10 into 1 minus z power of minus 1 plus I get cancelled, 2 1s are 2 10s are, so you will get 1 by 10 here, I get cancels, right? So here you can cancel, 2 1s are 2 10s are you will get, so I can write this as z by 2i plus 1 power of minus 1. Here also I get cancelled, 2 1s are 2 10s are, so minus 1 by 10 into, here I am going to take minus as a common term, so you will get plus 1 here. So when you take minus as a common term, you will get 1 minus z divided by 2i whole power of minus 1. Hope so it is clear now. See, first you resolve by using partial fraction, afterwards you consider the function by leaving the denominator. Now shift the denominator to numerator, you will get this. So if I apply directly the expansion, you will get confusion, so that is why I have written one more step, that by taking the common factor. So I have taken 2i as a common factor in this term, I have obtained this. Again I have taken, since I have minus in the denominator of a expression d, so that is why z minus 2i. Fine. Now let me take 2i as a common term, so you will get this term. Clear? For the fourth term, this is for the second term, this is for the fourth term. Now again I have to arrange it in a standard form, so that is why I have written this. Now you can expand, so minus 1 by 10 into, further no need to simplify, you just expand and keep the answer. That is, you will get alternatively negative and positive signs. Fine. Minus 1 by 10 into, here 1 plus z square plus so on you will get. Next third term plus 1 by 10 into, here when you expand this term, you will get alternatively minus and plus, that is minus 1 minus z by 2i plus z square by 2i square minus z cube by 2i cube plus so on. Next fourth term plus 1 by 10 into, here 1 plus x is 2i plus x square is z divided by 2i whole square plus x cube is z divided by 2i whole cube plus so on. And that's all. I'll just repeat these steps once again. Minus 1 by 10 as it is. Since you have 1 plus x form, so you have to put alternatively negative and positive sign. First it should start with negative sign. So this is as usual expansion. Again this is alternatively negative and positive. In place of x I have z by 2i. Now in this expansion 1 minus x power of minus 1. So it is 1 plus x square plus x cube and so on. Clear? So this is the required solution of a given problem. First step, see here, I have split it by using a partial fraction. Fine. In the next step, substitution. After that, taking common factor, expressing it in a standard form. After that, expanding it. So you might get confusion here. So you just understand the problem and try to solve yourself so that you will understand well. Hope so it is visible for you. Fine. I am showing you the problem once again, that's all. See. So you just copy down to the notes. Again I'll not send the notes. If you understand this concept, you can do by your own. So let me solve one more problem. So here is a problem. We have to expand this function by using Taylor series about the point z is equal to 0. So as I said in the beginning of the session, when they have asked you to expand about z is equal to 0, it is more or less we say Maclaurin series. So they can ask this as expand using Maclaurin series. So one and the same, you have to do the same procedure for both. You just write down the Taylor series expansion first. Taylor series expansion. It is given by f of z is equal to f of z naught plus z minus z naught divided by 1 factorial into f dash of z naught plus z minus z naught whole square divided by 2 factorial into f double dash of z naught plus so on. Next, let us consider a given function f of z as 1 divided by 1 plus z power of 4. I can write this as 1 plus z whole power of minus 4. Now we need f dash and f double dash. First you write f dash of z naught, that is f dash of z you find out, that is differentiate. You will get, see here f dash of z is, you just differentiate, it is of the form n into x power of n minus 1, minus 4 minus 1. So you can write this as minus 4 into 1 minus z power of minus 5, or else minus 4 divided by 1 minus z power of 5. Fine, I'll just do one. Next thing you have to do yourself. F double dash of z, you just differentiate this. You will get 20 divided by 1 plus z power of, it is plus 1 plus z power of 6 you will get. Similarly, if you want, you can do one more step, or else you can stop here itself. So let me expand now. About the point z is equal to 0, right? So you have to substitute z is equal to 0 wherever is necessary. So let me find f of z naught, in the sense f of 0. F of 0 is replace z with 0. So you will get 1 plus 0 power of minus 4. It is 1. Next, f dash of z naught we need. F dash of z naught is 0. So replace z with 0. You will get minus 4 divided by 1 plus 0 power 5. So it is minus 4 divided by 1. It is minus 4 only. Next, f double dash of z naught. It is f double dash of z naught is 0. So f double dash of z naught is 20 divided by 1 plus 0 power of 6. It is 20 only. So you can substitute directly. Now f of z is equal to f of z naught in the sense 1. Plus z minus z naught in the sense z minus 0 divided by 1 factorial into f dash of z naught is minus 4, plus z minus z naught is 0 square divided by 2 factorial into f double dash of z naught is 20 plus so on. So on simplification you will get 1 plus z divided by 1 factorial, that is minus, I will just put here only, minus 4. Next, plus z square by 2 factorial into 20 plus so on. So this is the required Maclaurin series or Taylor series expansion about the point z is equal to 0. Remember, Maclaurin series is same as Taylor series about z is equal to 0. I'll just put a note point here. Maclaurin series expansion is same as Taylor series expansion about the point z is equal to 0. That is Maclaurin, Maclaurin Maclaurin series expansion is same as Taylor series expansion about the point z is equal to 0. So hope so this problem is clear. You just take a screenshot and copy to notes. It is Maclaurin series expansion is same as Taylor series expansion about the point z is equal to 0. So here is the next problem. Here it is question is asked differently, that is to find the Maclaurin series, Maclaurin, Maclaurin series expansion of sin z. Maclaurin series is none other than, as I already told you, it is a Taylor series expansion about the point z is equal to 0. Fine. So here also we are going to use the Taylor series expansion, but the point is given directly that, indirectly that we have to expand about the point 0. So that is what the Maclaurin series meaning is. Now let us consider the series, that is the Maclaurin series. Maclaurin series is given by, you just replace z naught with 0 in Taylor series. Replace, I am just telling you manually, replace z naught with 0 in Taylor series. You just, if you want you can write separately Taylor series, and wherever z naught is there you just put it with 0. So f of z is equal to f of 0 plus I am writing directly here f z into f dash of 0 plus z square by 2 factorial into f double dash of 0 plus so on. So this is the required Maclaurin series. Now let us consider the given function as f of z. So it is sin z. Now differentiate f dash of z is equal to cos z. Now again differentiation of cos z is minus sin z. So again differentiation of sin z is minus cos z. So anyhow we are not interested in third derivative. Let me solve up to second derivative. It is more than enough. So f of 0 is sin 0. Sin 0 is 0. F dash of 1 is that is f dash of 0 is cos 0. Cos 0 is 1. Similarly f double dash of 0 is minus sin of 0 is minus 0. Minus 0 in the sense plus 0 only. Fine. Now since this term will be 0, so let me find f triple dash. F triple dash of z will be, anyhow f triple dash will be there. Let me write one more step here. Z cube by 3 factorial into f triple dash of 0 plus so on. So f triple dash will be differentiation of sign is cos z. So f triple dash of 0 is minus cos 0 is minus 1. Now let me substitute. The required series will be f of 0. So f of 0 is 0 plus z into f dash of 0 is 1. Plus z square by 2 factorial into f double dash of 0 is 0 plus z cube by 3 factorial into f triple dash of 0 is minus 1 plus so on. So f of z will be z plus 0. This 0 into anything will be 0. So you will get minus, I'll make minus here only, minus z cube divided by 3 factorial plus so on. So this is the required Maclaurin series expansion for the given problem. Fine. Now let me solve one more problem based on the Maclaurin series only. So second problem is e power of z. As usual, I am sorry, I am not going to write the statement again. You just write the Maclaurin series as I done it for the first one. So you write these two statements again here. The Maclaurin series expansion, you have to write Maclaurin series expansion is you have to write. So after that, let us consider f of z as e power of z. Fine. Now f dash of z is again e power of z. F double dash e power of z is e power of z only. F triple dash is also e power of z only. Now we need to find about the point. Why? Because we have asked it to find Maclaurin series. It is the Taylor series expansion about the point 0. So we have to find f dash of 0, f double dash of 0, f triple dash of 0. So wherever z is there, replace it with 0. Fine. So f of 0 in the sense e power of 0 is 1. Again f dash is e power of 0 is 1. Again the same e power of 0 is 1. A power of 0 is 1. So in the expansion, wherever f dash f of 0, f double dash is 0, f triple dash is 0, you have to put, if you have to replace it with 1. So you will get f of z is equal to 1 plus z square by 2 factorial plus z cube by 3 factorial. Please, I am telling you once again, please write the expansion here once again. Fine. Now, hope so it is clear. You just copy to the notes. And I am telling you once again, you have to complete it. Maclaurin series expansion is, you have to write the formula as I written it for first one. So you have to write the steps like this. Fine. Now here is the third problem. Anyhow, it is homework for you. Answer I have written here only. So please take it as homework and solve yourself. Please pause the video and write the problem in the notes and solve in notes only. Fine. Now here is the fourth problem. In the Maclaurin series, we have to find the Maclaurin series of this. So Maclaurin series is none other than, you have to write the statement, that is Maclaurin series expansion is given by, you have to write the expansion. Similarly, so this step you have to write Maclaurin series is given by, this step is common. Fine. Now let us take f of z as log of 1 plus z. Now let us find f dash of z. Differentiation of log x is 1 by x, that is 1 plus z. Now f double dash of z is minus 1 by x square, that is 1 plus z whole square. It is enough to prove find two terms. Now f of 0 you find out, you will get log 1, right? 0 plus 1 is log 1, again it is 0. Now f dash of 0 is 1 divided by 1 plus 0, it is 1. Now f double dash of 0 is minus 1 divided by 1 plus 0 square, it is minus 1. So you will get the Maclaurin series as z plus z square by, second term will be not there. So z square by, I'm sorry, first term will not be there. Z square by 2 factorial into minus 1 plus so on. That is f of z is equal to z minus z square by 2 factorial plus so on. So this is the required expansion, that is Maclaurin series expansion of a given problem. Hope so Maclaurin series and Taylor series is clear for you. Anyhow, I've given only simple problem as an homework. You solve these problems in the notes. Again, I'm telling you, these problems I will not send you again. You have to copy these important problems in your notes. And hope so whatever I have done, it is clear for you. Further, if you have any doubts, you are free to ask me. And if you further you have problems on few more problems on Lorentz theorem. So before starting with that, you have to go to the Lorentz theorem properly. Hope so you understand this concept. Continue in the next class.